Okay, so we're gonna look at transformation. Um, transformation is basically just changing the canvas instead of changing where the shapes are being drawn. So you can kind of think like in Photoshop. If I open up Photoshop real quick, if you've used Photoshop before, let's just use a small. So if you used Photoshop before, you can design a bunch of stuff. We can put some like rectangles and triangles and whatever. And in Photoshop, all of these things have transformation. So if I click on one of these guys, or if I put this all into one layer, so let's grab this whole thing and rasterize and merge into one. Okay, so if I have this like image, you can imagine I'm drawing these P5 shapes. If I go to, in Photoshop, if I go to transform, I have all these different options. So if I like scale, I can scale it up. If I do, and then I have to, Photoshop, I have to hit enter, but I can also hit Command T and you can rotate, you can scale, you can like flip, you can do all this different stuff. So these are different transformations, and what you're changing is if you look at the properties up here, you'll notice those changing. So for example, if I move this up and down, you can see these values changing, like the width and the height. And this, in graphics, we call this the transformation. So we're transforming the space of our graphics. You can see the rotation change if I rotate there. And there's other parameters. So that's essentially what a transformation is. In P5, when we use transformation, instead of deciding where to draw the circle or where to draw the square, etc., we're transforming the actual canvas the way that it's drawing on the canvas. So within our transformations, we have a few different properties. The first property is translate. Translate is just the origin position of our canvas. And so in this example, you see some code, and if I change the X value, even though this rectangle is still being drawn in the same place, this ellipse is still being drawn in the same place, the origin position of our canvas changes. And so I'll give an example here. So I'll first draw an ellipse at 0, 0, 100, or let's just do a circle. So in the default canvas, that circle is just in the top left corner. That's the origin point of our canvas. That's where 0, 0 is. But if I translate, so if before I draw the circle, I translate the origin. So let's say translate, let's go to 100, 100. The circle changes. So my circle is still at 0, 0, but what's changed is the original position of our canvas. And so we can, make the canvas start in the center. So, it's kind of like that, like in CSS, but it's more just like we're changing the sort of like when we tell our graphics where we want them to be, we're using the X and Y positions. And what this is doing is actually changing the orientation of where that is. So we're starting from a different point. So yeah, so if I translate, and I don't have to translate to the same number, I could translate over here. And so we're basically just like moving the grid that we're drawing on. And so remember we talked about the Cartesian coordinate system. This is like what we use in math. It kind of has this is the middle point, and then the X goes up from there, or down to the left, or Y goes up and down. That's like the Cartesian coordinate system. Our coordinate system is a little different. We started 0, 0 as the top left, and X still goes positive to the right, but Y goes positive down. And so this is actually basically just moving where that grid starts. And so this can be useful if you want to do a design but you want to start everything from the center of the canvas rather from the top left, maybe that's easier to think about. Like if I translate to the very center of the canvas, then when I want a circle in the center of the canvas, I don't have to do any math. I can just go to 0, 0. So it's useful for stuff like that, but it's also useful for doing other transformations. And when we start to combine transformations, then that's when it's really necessary. Okay, so we can also rotate. And this is where we may want to combine translate and rotate. So in this example, if we translate at 0, 0, when I rotate, we're going to rotate around that point. So notice when I rotate here, we're sort of rotating everything in the canvas. But if we rotate from 0, 0, pretty quickly we're rotating outside of what we can see. So if we add these together, if I translate into the middle of the canvas first, now we can see that full rotation. So we can take a look at that. It's not going to be visible with the circle, because if I rotate, a circle is just a circle. So if I rotate by pi, and we measure rotation in pi, remember that's how we measure the angle of a circle. With the circle, it's just round, so we don't see any difference. But if I take a square and draw that, then we'll see the difference. So if I don't rotate, our square starts at the top left, that's 0, 0, it draws down into the right. When I rotate half a circle, we've rotated around to the beginning. And you can also notice if I move this pi down, if I draw a square and then draw another square, so I'm going to draw the exact same square. The first one is not rotated, and the second one is. So we translated here, and then we draw this circle in the square, and then I rotate by pi. And so our second square is rotated around, even though the code is exactly the same. So this square is at 0, 0, this square is also at 0, 0, but the first square is how it would normally be, and the second square is rotated all the way around. And I can rotate by less than a circle, so if I rotate by like pi times 0.5, then we just rotate 90 degrees. If I rotate by a quarter pi, then we just rotate around a little bit. If I go less than that, we rotate at different increments. To show the rotation, what I could do is I could say variable r equals map. So I'll map my mouse x. I'll say mouse x. So I'll map across the canvas from 0 to width. And what I'll map is from 0 to 2 times pi. So pi is half of a circle rotation. So I'll go from 0 to pi times 2. And so now we'll see that full rotation. Oh, I forgot to use R. So now I have to rotate by R. Okay. So now you can see the rotation mapped to the mouse position. So that's how we can rotate shapes and, rotate an entire composition with just one thing. And again, this is just like our colors, this adds up. So if I move these shapes, if I move these shapes down here after I rotate, then they're all going to rotate. So the order that we draw them in determines, if they have those transformations or not. Okay, let's keep going. So we can also transform the scale. And the scale also matters for translate. So let's set the translate back to the origin, 0, 0. And when I scale, notice that we scale into that top left corner. Whereas if I translate into the middle, we're going to scale into or out of the middle of the canvas. So scaling just kind of zooms in or zooms out. So if we scale here, I'll scale by 2. So notice our first circle and square stay the same because that happened before we scaled. And then I scale up by 2, and now my second square, even though it's still 100 pixels wide, is scaled up. So that square is twice as big as the other shapes. And we can animate the scale as well. If I want to put scale down here, and let's say or S for scale equals map mouse Y from 0 to height, 0 to 2. Or actually, we don't want to scale 0 because then it'll be invisible. Well, I guess we could scale 0. 0 to 2, and then let's clamp that so we don't scale negative. So then I'll scale by S. And so now you can see scaling from 0 up to 2. So I have rotating on the X and scaling on the Y.
Why did you put a true again?
True is to clamp the range of the map function. So right now I have 0 to 2, but if I go past 0 here, I don't want it to go negative. If I take this out, I think they actually changed the way, yeah, so it actually doesn't do this anymore because it used to read the mouse past the edge of the canvas. So it actually doesn't really matter. Oh, but you can see it here. Yeah, you can see it's actually scaling. It's still scaling when I go. See how my mouse is below the canvas, but it keeps going? So if I clamp this value, then it doesn't go past that 2. So clamp basically just says if you get to 2, don't keep going. All right, so we have scale. We also have shear. Shear is a little bit more complex mathematically, but it's like you can get some cool effects from it. So what shear does is it basically rotates an angle, and then it moves, as you get farther away from the origin, you move at that angle farther away. So in a typical default, if I translate on X, I just move right on X. If I translate on Y, I just move right on Y. But if I shear on X, you're going to see that it changes this angle. So in this example, I'm just visualizing this, but you can see that it's affecting the design as well. So it rotates everything at a little bit of an angle, and then stuff that's farther away from the origin, it moves farther away. So you can see these points down here are moving out by that angle. And then it changes this sort of like origin. So when I move on Y, I'm moving at this angle rather than up and down. When I move on X, I'm still moving on the X axis. So it just changes this sort of angle of this origin rather than the full rotation. So we can do that on the Y-axis as well. So now you'll see if I shear a bit like this, now if I translate on X, now it moves on the angle, whereas on Y it still just moves straight up and down. So you're essentially isolating the rotation of the canvas to one axis. So that one's a little more confusing, but you can get some kind of cool effects. You can see it kind of looks like almost like 3D a little bit because we're getting this like weird perspective. So, you know, you can, here's I've mapped the mouse to shear these two different circles, and you can see as I go across, they kind of flatten out in this weird way. So you can get some kind of cool effects with that. Okay, so then with our transformations, sometimes you want to do multiple transformations, but they're going to affect each other. And so this is where push and pop comes in. Push and pop is a little confusing, but basically what's happening is as you make these transformation changes to the canvas, you can basically add them to like a stack. You can think of a stack as like a stack of pancakes. So when you make a pancake, you put it on the bottom, and you make a second pancake, that goes on top, and then you eat the first pancake on the stack, and then you go back to the bottom. So with push and pop, we make a stack of transformations. And so as we make each transformation, you can save it, and then if you want to get rid of the transformation, you can pop it. So I'll show you an example of that. If I push here, I'm adding everything up to this point, and then if I pop at some point, it's going to undo whatever is there. And you can do this multiple times, but I won't do that because it'll get kind of complicated. So let's say I actually pop right after I draw my circle and my square. What happens is now my this square over here has gone back to the origin point, because I basically saved this translation and then I got rid of it by clicking pop here. So push and pop is basically just a way that you can have multiple different transformations that affect different parts of your sketch. This will be, this gets a little more complicated. You might not need to use this, but it can be useful if you have a specific thing. I want to have one thing rotating over here and the other over here, then I might need to push and pop. Of what? Yeah, kind of. Yeah. So yeah, let me do another example of that, and I'll do some animation. So I'll leave this one here for a second, and let's make a new sketch. So I'll just add this to our collection, and then we'll make a new sketch, and I'll just do a push pop example. Okay, so let's say I have two squares. So I'm going to translate to 100 and 300, and I'm going to draw a square at 0, 0, 100. Let's just go to 200. Okay. And then I'm going to translate over again by 200 and do another square. So I have the same code for both my squares, but there's a couple things that I'm going to change in a second. So now let's rotate. So for this, I'm going to do a little animation. So I need to make a variable for R. So I'm just going to set R to 0. And then I'm just going to increment R each frame. So I'll do that down here. I'll say animate rotation. I'll say R plus equals, I'll do something small. So I'll do pi times 0.1. I might do even smaller than that, like 0.01. We'll see how that looks in a second. Okay, so I'm going to rotate here. And what we're going to see, well, you'll see in a second. So I'm going to rotate by R. And so we see it's rotating, but the problem is both squares are rotating from the same point because our transformations add up together. So I'm like, okay, maybe I need to rotate twice. So I'll copy this and I'll go down here. And so now I'm getting one rotation that's, now I have two rotations, but the first rotation is getting added to the second rotation. So it's kind of cool looking, but it's not exactly what I want, right? So I want to isolate this rotation. So I can push and pop up here. So I'll push, So I'll push here. And then after I draw my square, I'll pop. Okay, so now I've isolated my first rotation. And so now my second rotation only affects the square. Okay, so I push before the rotate. If I push before the translate, then I'm going to get a different issue, which is now my two translations don't work. So you might want to do it that way. I can just change this translation. So all I really did was, change this. So I could translate 300 by 200. And so now I've got my two rectangles. And maybe that's a little bit easier to read, so maybe I'll leave it that way. But there are multiple ways to do it. So now I'm basically pushing, so I'm essentially adding the original transformation, like before anything has happened. I'm saving that. And then I'm translating and rotating and drawing my square. And then I'm popping back to that original transformation. So now I can do a different translate, a different rotate, and I can have a separate rotation for my square.
So that's basically like you're locking the animation to that figure, right?
Sort of, yeah.
I have no voice. Sorry.
Yeah. I'm sort of saying like any transformations that happen in here are, done, and then we're going to start from scratch again. So yeah, again, that's only if you want to have multiple things that are using different transformations. if you don't need to do that, then it's not really necessary. Okay, so let's push and pop. So we already did this, but we can animate with our transformation. So here I was just like adding a little bit to pi. And I'm just using pi. You don't really have to use pi here, but it just means it works in terms of like a rotation value. So it doesn't really matter. You're just adding numbers, but it just makes you think basically you're doing 0.01 of a half rotation every frame. So it makes it a little bit easier to think in terms of rotation. But we can animate things like scale as well. So let's make a variable for scale. And actually, we probably want to start at 1, not 0. So we'll scale at 1. And then maybe I want to scale the whole thing. So I'll put this even before my first rotation. And so I'll say scale as S, and then I'll say scale plus equals 0.1. So I'll scale a little bit each frame. But it's getting way too big, so let's scale less than that. Okay, so it's getting really, really crazy. We probably need to scale. I might actually want to scale inside here and then down here. Okay, yeah, that makes more sense. We don't want to scale before. So our scale eventually is going to get too big, and so this is a case where we might want to control this. So just like we did previously, let's bring this down here. So the rotation can keep going forever because the rotation just goes in a circle, but obviously the scale gets too big at some point. So let's say scale or animate scale. So we can just say if S is greater than 2, that can be like the highest scale we want. We can either reset scale, or if we want to do reset the direction, we go through adding in the speed. So we can just set scale back to 1 here. Oh, I took out my... So we'll say S equals plus equals 0.01. We need to use a very small value here because it gets bigger very fast. And so you can see now the scale is kind of resetting. It's resetting at an awkward moment because our rotation hasn't finished. So maybe I could map the scale to the rotation. I could say something like scale equals map. Actually, then I wouldn't even need to use this. No, I still would. So I could say like scale equals map 0 or R from 0 to pi 1 to 2. Actually, I don't really know what this is going to do. It doesn't seem to do anything. Let's print out, or I'm just going to show scale on the screen. Maybe we can see what's happening. Uh-oh, it's rotating around. Let's move that up here before we translate. Okay, so it's just stuck at 1. So why is that happening? So R is starting at 0, and we want to know as it's getting bigger. Oh, I put a plus equals. That's stupid. Okay. Okay, so now we've mapped scale to rotation, and what we really want is one full rotation, so pi times 2. So now they're going to scale, and then they reset there. And then the problem is here is we're not going to get to 2 exactly, so let's set 2 here. Oh no, the problem here is that R is not going to reset. Okay, so that's not the best idea. We'd have to do some other stuff for that. So let's just change this back. Okay. So now our scale and our rotation is offset again, but that's okay. If we wanted to, we could figure out that math and make that line up correctly. So yeah, we can animate scale, we can animate rotation. You could animate shear if you wanted to get something weird. Let's see what happens if we shear the whole thing. Let's shear. I think this is going to look kind of crazy, but let's make another variable called shear x. Or no, that's the function name. I'll just call this SX start at 0. So we'll shear SX, and we'll say SX plus equals 0.01. This is going to get really weird pretty quickly, I think. But eventually it's going to reset. Let's make these shapes a lot smaller. It'll be easier to see what's happening, or maybe not. I think the scale, let's set the scale to like 1.2. It's still going way off the screen. It's kind of cool though. Maybe if we translate at the beginning, but that's gonna ruin all our translations. Anyway, that's another thing you can do. You can do a lot of weird stuff, but eventually, you know, it starts to get. One of the things that's annoying is that when this stuff is going off the screen, you don't really know what's going on or why. So that's what you have to look out for. Probably what's happening is that the shear origin is still the top left, so it's kind of like going around that top left rather than the center of the canvas. So what I would want to do is translate here to like 200, 200. But then the problem is that we have these translations. So let's set this to, this would be now like negative 100, 0. And this would be plus 100, 0. This is getting overly complicated, but okay, so now we have this crazy shear and scale and rotation. So it's kind of fun, and you can do that. The thing that may not be clear, since I'm just using these default shapes, is that this will do the same thing with an image or text or anything else that you put in the canvas. So if I have some text here, if I have text that says like hello, and let's make the text size bigger, it's going to do the exact same thing. So anything that we have on the canvas is going to take on these same transformations. Okay, let's get rid of the shear for now, just to simplify this a bit. And I'll return these sizes back. And so now we just have a weird hello box animation, but that's kind of fun. And let's change this to push and pop and animation example. Okay, so the main thing that we want to do this week is just work on animation, but the transformations give us more options for the types of animations that we can do. We can animate more than just the position or color or size. We can also use the rotation and these other transformation possibilities. All right, so that's it for now. Any questions or anything you guys want to review? Okay. Yeah.
The map function. Yeah. I don't understand that quite right.
The map function? Yeah, so I think it's the map function is just basically doing some simple math, but you can use it in a lot of different contexts. So that's actually a good example of something that you might want to do is tie one animation to another. So let's try that again. I'll make a new example, and I'll just say, I'll call this map animation example. Okay, so last week we were using the map function just to map our mouse position to a value on the screen. But we can use the map function for lots of different things. So one of the things we can do is we can tie one animation to another in different scales. So let's say we're just rotating. So I'm going to translate to the center of the canvas. I should use more comments. Translate to center of canvas. And then rotate, or let's draw a square at the origin, and animate rotation. So we're just gonna do, oh, we gotta put our square down here. So rotate, and we're gonna use R as a rotation number. So we'll say R equals, R equals 0. And so then we're just gonna say R plus equals pi times 0.1 or 0.1 or maybe 0.5, or let's do 0.25. Okay, so we've got this little rotation animation going on. And so that looks pretty cool. One thing that's a little confusing with the rotation, so before when we were animating the circle bouncing, we had to reset. We don't have to do that with rotation because it just keeps going when we get past pi. But we could say if R is greater than pi times 2, R equals 0. So now we don't really see any difference here, but if we look at what R is, so let's draw some text and we'll put R in there at 0, 0. Let's do it before we rotate. Okay, so if we look at what R is, you can see it's just the number that expresses the rotation, and it's going from 0 to pi times 2. So one full rotation is 2 times pi. So pi is something like 3.14, etc. And so we can see we get basically to 6, a little above 6, and then we reset to 0. And so let's say we want another animation that matches our rotation, but it's not in the same scale. So we could do color. Okay, so let's say I want to animate the color. So let's choose a color. Let's just use B for blue. And we'll start blue at 0. And what we'll do is we'll say fill, and we'll say do like 0, 0, and B for blue. Okay, so our color is black, but we could, if we say B equals R, then we're setting the blue value. Let's give these real names. So I'm gonna call this ROT for rotation, and I can't use blue because it's a function, but what could I use instead? Let's just call it color B. Okay, so let's get rid of these for a second. So we're rotating by ROT, and then we're incrementing ROT, and we're resetting ROT, and then we're setting our color B to our rotation. And we got to set our color B here. Okay, so now we're actually changing the color B, but because the highest value the rotation ever gets is like 6, we don't see that at all. We could multiply it. We could say like times 10. And so now you see it's starting to turn blue. Or we could say times 20. And so you can see the blue color is coming in, but we don't get to the full blue because we're not using the full scale. So instead of just mapping it directly to whatever rotation is, what I could do is I can map the range. So I can map the rotation. The rotation exists on a scale from 0 to 2 pi, right? Because when we get to 2 times pi, we reset. So we can map from 0, which is a starting rotation, to pi times 2. And instead of going from just those values, we can map to a color range. So we can say 0 to 255. So now we're going to get that full blue. But the nice thing here is they reset at exactly the same time. So if I slow down this animation, now we're going to see that the blue and the rotation reset at the same time. And now if I change any of these values, I can update that as well. I can map it the opposite direction. That's the nice thing about map is that once you have that set up, you can make a lot of different changes just by switching some of these values. I could say I don't ever want it to go to 0 blue, so I could just map to 100. So it's kind of fading out, but it doesn't ever go fully to 0. So the map function is basically just taking 2 ranges, and it's mapping one value from the first range to the second range. Is that That's clear? Okay, cool. Any other questions or review? Okay. So let's